Good morning, students. Let us continue from where we have stopped yesterday. The previous class, we have worked out some examples of variable separable method from the textbook. So let us start from ninth problem onwards. Solve dy by dx is equals to sine of x plus y plus cos of x plus 1. So to solve this, let us take x plus y is equals to t. Let x plus y is equals to t. So the very first thing that should strike to our mind whenever we take the substitution is differentiating with respect to this independent variable x. So differentiating with respect to x, we get d by dx of x is 1 plus d by dx of y is dy by dx is equals to d by dx of t is dt by dx. So from which dy by dx equals to dt by dx minus 1. Substituting this dy by dx into the given equation, given differential equation. So substituting dy by dx in the given differential equation, we get dy by dx is replaced as dt by dx minus 1. So dt by dx minus 1 equals to sine x plus y is t plus cos x plus y is t. So this is equals to dt by dx equals to 1 plus sine t plus cos t. So separating the variables, we get, so this is dt by 1 plus sine t plus cos t is equals to dx. So this I have brought on to here, and 1 by dx if you take to that side, that is dx into 1 is dx, and integrating on both sides. So before integration, let us take this. Otherwise, separating the variables, we get integrating on both sides, we get integrating on both sides, we get, so integral, this is 1 by 1 plus sine t plus cos t dt is equals to 1 dx. So this is equals to, we know how to solve this, 1 by 1 plus sine t plus cos t. So let tan t by 2 is equals to some s. The other variables I'll take. Now tan t by 2 equals to s. Differentiate. Let us take this whole to be t. d by dt of t is tan t. d by dt of tan t is secant square. So this is secant square t by 2 into d by dt of t by 2 is 1 by 2 dt is equals to ds. From this, dt is equals to 1 by 2, if you brought to that side, that is into 2 ds by secant square t by 2 can be written as 1 plus tan square t by 2, because secant square x minus tan square x equals to 1. Secant square is 1 plus tan square x. This is 1 plus tan square t by 2. This secant square t by 2 is 1 plus tan square t by 2. So this is equals to 2 ds by 1 plus tan t by 2 whole square. This is s square. So, and sin t can be written as sin t in terms of tan. That is 2 tan t by 2 by 1 plus tan square t by 2. That is 2 s by 1 plus s square. And cos t is cos 2 theta in terms of tan is 1 minus tan square theta by 1 plus tan square theta. Half angle formula. Cos t is 1 minus tan square 1 minus tan square t by 2 by 1 plus tan square t by 2. This is 1 minus tan square t by 2 by 1 plus tan square t by 2. This is 1 minus s square by 1 plus s square. So now this implies, so here 1 dt by this. So in the place of dt, I'll take 2 ds by 1 plus s square by 1 plus sin t can be replaced as 2s by 1 plus s square plus cos t can be replaced as 1 minus s square by 1 plus s square is equals to integral 1 dx. So this is equals to 2 ds by, so 1 plus s square. This is LCM is 1 plus s square. The LCM is 1 plus s square. Now this is 1 plus s square plus 2s plus 1 minus s square by, the LCM is 1 plus s square is equals to 1 dx. So here this 1 plus s square by 1 plus s square gets cancelled. So this is 2 into ds by, so s square gets cancelled. 1 plus 1, 2, 2 plus 2s. Take 2 in common. This is 1 plus s is equals to 1 dx. So 2 gets cancelled. Integral 1 by 1 plus s ds is log 1 plus s. So this is log 1 plus s value is tan t by 2. Tan t by 2 is equals to 1 dx is x plus constant of integration c. But this is not the answer because the given differential equation is in terms of x. But here we got in terms of x and y. Here we got in terms of t. So substitute t by x plus y back in the given equation. So therefore log 1 plus tan, the value of t is x plus y by 2 is equals to x plus c is the required solution. Solve x minus y whole square dy by dx equals to a square. So this is equals to, let x minus y is treated as t. So differentiating we get 1 minus dy by dx equals to dt by dx. Therefore 1 minus dt by dx is equals to dy by dx. Substitute here. X minus y is t square. Dy by dx is 1 minus dt by dx is equals to a square. So this is equals to t square minus t square dt by dx is equals to a square. So this is t square minus a square is equals to t square dt by dx. This is equals to, so this is t square by separating the variables. Separating the variables, we get t square minus a square by otherwise t square dt. T square dt is same. This t square minus a square is divided with this. So t square minus a square. This is 1 by dx. If you transpose onto this side, this is dx. And integrating on both sides. Integrating on both sides, we get this. Now, this can be simplified as t square dt. So for this, I'll subtract a square and add a square without loss of generality. Minus a square plus a square gets cancelled. We are left with t square only dt by this is t square minus a square dt is equals to integral 1 dx. This is equals to integral. This is a plus b by c. A by c plus b by c. So t square minus a square by t square minus a square gets cancelled. We are left with the integral 1 dt plus a square, since it is a constant, separate it from the process of integration. A square integral 1 by t square minus a square dt is equals to integral 1 dx. So this is equals to integral 1 dt is t plus a square. So we know what is integral 1 by x square minus a square. T is a variable, therefore it is to be treated as x square minus a square. Integral 1 by x square minus a square is 1 by 2a log mod x minus a by x plus a. So this is 1 by 2a log modulus of t minus a by t plus a. So is equals to integral 1 dx is x plus constant of integration c. So here a and a gets cancelled. So this is equals to the value of t is x minus y. So this is x minus y plus this is a by 2 log the value of t is x minus y minus a by x minus y plus a is equals to x plus c. So here x on both the sides gets cancelled. So therefore this is y is equals to, so y is equals to this y, if you take on to another side, then this is y is equals to a by 2 log x minus y minus a by x minus y plus a plus c. This minus y, I have brought this onto another side. This plus c, if I brought to here minus c also can be written as c dash is the required solution. 11th question, solve in 1 plus x square under root into root of 1 plus y square dx plus xy dy equals to 0. First of all, this can be written as 1 plus x square into 1 plus y square dx is equals to, on transposing, this is minus xy dy. Now this is equals to dy by dx. Now this is separating the variables, we get this is root 1 plus x square dx. This x is multiplying with them y dy, so it will be dividing here. This is equals to minus, this is y dy by, this is root 1 plus y square, so it will be dividing. So root of 1 plus y square. So integrating on both sides, we get integral root 1 plus x square by x dx plus this is this minus, if you transpose onto this side, this is plus y dy by root 1 plus y square is equals to 0. So now this is equals to, how do we do this? So this is easy because this is 1 plus y square derivative should be 2y. So I will multiply with the 2 and divide. Then f dash x by f of x, 2 root f of x, this is easy. But how do we solve this? So for this, I'll take, let 1 plus x square is equals to, whatever that is under root, let us take t square. Instead of t square. So that square and root will be eliminated. T square. Now, differentiating 2x dx is equals to 2t dt. So 2 gets cancelled. So this is equals to root 1 plus x square by x dx is equals to integral root 1 plus x square is root t square, which is t, dx. From this, what is dx? Dx is equals to t dt by x. So here dx is t dt by x into x. Dx is t dt by x. T dt by x. So here already one x is there. X into x, x square. So this is equals to t into t square dt by x square. 1 plus x square is t square, but x square is t square minus 1 from this. T square minus 1. So now this is equals to now you consider this integral 1 plus x square by x dx plus y dy by root 1 plus y square equals to 0. You consider this. Consider. Now this is equals to this 1 plus x square by x dx, we got this. This is t square dt by t square minus 1 plus this, as we discussed before, 1 plus y square derivative is 2y. So I'll multiply this y with 2 and I'll divide with 2 also. So 2y dy by 1 plus y square equals to 0. So this is equals to t square. Now I will subtract with 1 and add 1. So t square minus 1 plus 1 by t square minus 1 dt plus 1 by 2. This is 2y dy by root 1 plus y square equals to 0. Now this is equals to a plus b by c. A by c plus b by c. So t square minus 1 by t square minus 1 gets cancelled. We are left with 1 dt, integral 1 dt plus, this is 1 by t square minus 1 dt plus 1 by 2. This is f dash y by root f of y, because 1 plus y square derivative is 2y. Therefore, this is f dash y by root f of y. So 2 root f of y. Remember the results. 2 root 1 plus y square is equals to 0. So this 2 gets cancelled. I'll tell you again. 1 plus y square equals to t square, otherwise you take. So 2y dy equals to 2t dt. So 2 gets cancelled. So therefore, otherwise don't cancel it. Now what is 1 by 2 into, what is 2y dy? 2t dt by root 1 plus y square is root t square, that is t, simply this is. So 2 gets cancelled. This is 2 gets cancelled. So integral 1 dt. So integral 1 dt is t. And what is t? Root of 1 plus y square. So if you don't know the result directly, then actually you may adopt this process also. So this is equals to integral 1 dt is t plus, this is integral 1 by t, you consider it as x square, 1 you consider it as a square. So we have the formula 1 by integral 1 by x square minus a square. Formula is 1 by 2a log t minus 1 by t plus 1. We have the formula. So plus the root of 1 plus y square. So since the process of integration is over, see, I'll write. Now this is equals to t value is equals to how much? Root 1 plus x square. So root 1 plus x square plus root 1 plus y square plus 1 by 2 log t value is root 1 plus x square minus 1 by root 1 plus x square plus 1 is equals to C is the required solution. Solve dy by dx equals to x minus 2y plus 1 by 2x minus 4y. So you may assume that it is a, so because a non-homogeneous differential equation is of the form dy by dx equals to ax plus by plus c by a dash x plus b dash y plus c dash. So otherwise we may take it as, so instead of going into the details and apply through the process of non-homogeneous differential equation, let us do x minus 2y plus 1 by, so 2 I'll take common, then x minus 2y, and take x minus 2y is equals to t. Now you may go through the process of variable separable methods that we have used before. So differentiating, we get 1 minus 2 dy by dx is equals to dt by dx. Differentiating with respect to x on both sides, we get. So 1 minus dt by dx is equals to 2 dy by dx. So this is equals to 1 by 2 into 1 minus dt by dx is equals to dy by dx. This 2 is multiplying, so I just transposed onto another side. Now substituting dy by dx in, let us suppose this to be 1, in 1. So that implies what is dy by dx? 1 by 2 into 1 minus dt by dx is equals to the value of x minus 2y is t. So t plus 1 by this is 2 into x minus 2y is t. So 2t. So 2 on both the sides gets cancelled. So this is equals to 1 minus of t plus 1 by t is equals to this minus dt by dx. If you transpose onto another side, this is dt by dx. So this is equals to t minus 1 by t. Finding LCM, we get this. So t gets cancelled is equals to dt by dx. Now, separating the variables and integrating on both sides. Then we'll get this is t dt is equals to minus 1 dx. T dt. See, this is transposing 1 by t on transposing the other side, it is t dt. Minus is there, minus 1 into dx is minus dx. T dt is equals to minus 1 into dx. So now integrating on both the sides, this is what we'll get. So integral t dt is t square by 2 is equals to integral 1 dx is minus x plus constant of integration c. So this is equals to t square by what is t? T is x minus 2y. So x minus 2y whole square. T is x minus 2y. T square is whole square by 2 is equals to minus x plus c. So this is equals to x minus 2y whole square is equals to 2 into minus x minus 2x plus 2 into c 2c. Therefore, x minus 2y whole square. This minus 2x, if you transpose onto this side, this is plus 2x. 2c is a constant. We can take it as c dash is the required solution. Solve dy by dx plus 1 is equals to e power x plus y. Let x plus y is equals to t. Differentiating as usual with respect to x. This is 1 plus dy by dx is equals to dt by dx. So therefore, 1 minus dt by dx is equals to dy. No. So dy by dx equals to dt by dx minus 1. This implies dy by dx, otherwise 1 plus dy by dx itself is dt by dx. This step is also not needed. This is 1 plus dy by dx is dt by dx is equals to e power x plus y is t. Now, now separating the variables and integrating on both sides. We get, so this is dt by e power t is equals to dx. 1 by dx, if you transpose onto another side, it is dx. So integrating on both sides. 1 by e power t is nothing but e power minus t dt is equals to integral 1 dx. So integral e power minus t is minus e power minus t is equals to integral 1 dx is x plus constant of integration c. Therefore, x, this minus if you transpose onto another side, this is plus e power minus of t value is nothing but x plus y is plus c is equals to 0 is the required solution. Solve dy by dx equals to 3x plus y plus 4 whole square. First of all, we cannot separate it. So, a plus b plus c whole square, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. 2ab, that means x and y will be mixed with each other. In that case, it is very tougher task for us to separate the variables. Therefore, instead of thinking in that way, let us take this to be some t. Let 3x plus y plus 4 is equals to t. Differentiating with respect to x on both sides, we get, so 3 into d by dx of x is 1. So 3 into 1, 3 plus d by dx of y is dy by dx plus d by dx of 4, which is a constant, is 0, is equals to d by dx of t is dt by dx. So from this, dy by dx equals to dt by dx minus 3. Substituting dy by dx in the given differential equation, we get, so dy by dx is dt by dx minus 3 is equals to, this is t square, so t square. So this is equals to dt by dx is equals to t square plus 3. Separating the variables, and integrating on both sides, we get dt by t square plus 3. dt by t square plus 3 is equals to 1 by dx. If you transpose onto another side, it is into dx. So dx. Now integrating on both sides. This can be written as 1 by t whole square plus 3 can be written as root 3 whole square integral 1 dx. Let us treat this t to be x. So we have the formula 1 by x square plus a square, 1 by a tan inverse x by a plus c. So here a is root 3, 1 by a is root 3 tan inverse x by a, that is t by root 3 is equals to integral 1 dx is x plus constant of integration c. Therefore 1 by root 3 tan inverse, so replace t by what we have taken before, 3x plus y plus 4 by root 3 minus x equals to c is the required solution. Solve dy by dx minus x tan y minus x equals to 1. This is the last problem from the variable separable method examples. So let y minus x equals to t, I'll take. Differentiating with respect to x on both sides, we get dy by dx of y is dy by dx minus dy by dx of x is 1, dy by dx of t is dt by dx. From this, dy by dx equals to 1 plus dt by dx. Substituting dy by dx in the given differential equation, we get dy by dx is 1 plus dt by dx minus x tan y minus x is t is equals to 1. So 1 on both the sides gets cancelled. So from this, dt by dx is equals to x tan t. So wherever we see, only t and x are what are seemed to be found. So we can separate the variables t and x. So separating the variables, we get, so this is dt by tan t, because tan t is multiplying with the x. If you bring here, it will be dividing. So this is equals to x dx. So integrating on both sides, we get 1 by tan t is cot t. So integral cot t dt is equals to integral x dx. So this is equals to integral cot t dt is integral cot x dx log mod sin x, because cot is cos by sin. Sin t is f of t, its derivative is f dash t. So f dash t by f of t. So log f of t, so log sin t. So this is equals to log sin t is equals to integral x dx is x square by 2 plus constant of integration c. So therefore log sin, the value of t is y minus x square by 2 is equals to constant of integration c is the required solution.